Have you ever wondered how the universe came into existence? This vast expanse of galaxies, stars, and nebulae that we call home didn't just appear out of nowhere. Its birth, an event of cosmic proportions, has been the subject of intense scrutiny and speculation by scientists and philosophers alike. From the earliest civilizations gazing at the night sky to the cutting-edge research in astrophysics today, the question of how it all began has been a constant source of intrigue. Theories abound, from the Big Bang to the concept of a cyclic universe, each providing a unique perspective on the origins of everything. And why is this important? Well, understanding the birth of the universe helps us comprehend the fundamental laws that govern it. It's like piecing together an enormous cosmic puzzle, and each theory, each discovery, is a piece that brings us closer to the complete picture. The birth of the universe is a topic that has intrigued scientists and philosophers for centuries. Let's delve into this fascinating subject. The dominant theory about the universe's birth is the Big Bang theory. This theory posits that our universe sprang into existence as a singularity around 13.8 billion years ago. Now, what's a singularity, you might ask? It's a point in space-time where the laws of physics as we know them cease to function. In essence, it's the heart of a black hole, infinitely dense and infinitely small. From this incomprehensible point, the universe started expanding, cooling, and developing. As it expanded, matter started to form, eventually giving birth to atoms, stars, and galaxies. The universe has been expanding ever since, a fact that Edwin Hubble, an American astronomer, confirmed in the 1920s. But let's take a moment to appreciate the vastness of the universe we're talking about. It's estimated that our observable universe is about 93 billion light-years in diameter, filled with roughly 2 trillion galaxies. That's a whole lot of space and a whole lot of stars. Now, if the Big Bang theory makes you feel small, the concept of the multiverse will make you feel even smaller. This theory suggests that our universe is not the only one. Instead, it's part of a vast ensemble of universes known as the multiverse. Imagine a cosmic bubble bath, with each bubble representing a separate universe. Each of these universes could have different laws of physics, different types of matter, and maybe even different dimensions of space and time. Some could be very similar to our own universe, while others could be vastly different. The concept of the multiverse expands our cosmic horizons, taking them from the immense to the virtually infinite. But remember, these are just theories, interpretations of the evidence we've gathered so far. As our understanding evolves, so too will our theories. As compelling as these theories are, they are not the only ideas about the universe's birth. Besides the Big Bang theory, scientists have proposed other fascinating theories. One of these is the steady-state theory. This idea suggests that the universe doesn't evolve or change in appearance over time. Instead, it asserts that new matter is continually created to maintain a constant density as the universe expands. This theory challenges the Big Bang's concept of a singular point in time when the universe burst into existence. Next, there's the oscillating universe theory, which proposes a cyclic model of the universe. It's a bit like a cosmic accordion, expanding and contracting in a never-ending cycle. In this model, the universe undergoes repeated cycles of big bangs and big crunches. Each big crunch, where the universe collapses back onto itself, is followed by a new Big Bang, beginning another cycle. This theory offers an alternative to the one-time event proposed by the Big Bang theory. Finally, we have the quantum fluctuation model. This theory suggests that our universe might have originated from a quantum event in the vacuum of some larger space or even another universe. In this model, a tiny quantum fluctuation, smaller than an atom, could have expanded through inflation into the vast cosmos we observe today. Each of these theories adds a unique perspective to our understanding of the universe's birth. They challenge the conventional Big Bang theory and introduce the possibility of an eternal universe, a cyclic universe, or even a universe born from quantum events. These theories, while not as widely accepted as the Big Bang, offer intriguing possibilities for the universe's birth. The quest to understand the universe's birth is ongoing, with scientists making new discoveries and developments. One such discovery is that of a rapidly growing black hole, known as GNZ7Q. Using data from the Hubble Space Telescope, scientists found that this black hole, which existed a mere 750 million years after the Big Bang, is cloaked in dust and emitting ultraviolet and infrared light. This indicates that it's growing quickly and will eventually become a quasar. This discovery is drawing a link between the universe's first supermassive black holes and young star-forming galaxies, and it's shedding some light on how the universe formed. But the discoveries don't stop there. Scientists have also laid their eyes on a massive exoplanet, AB Aurigae b, that's still in the early stages of formation. This planet, estimated to be about 9 times the mass of Jupiter, is embedded in a disk of gas and dust surrounding a star called AB Aurigae, situated 508 light-years away from Earth. This discovery challenges our current understanding of planetary formation, as AB Aurigae b is forming at a larger orbital distance than previously thought possible. And then we have physicists making strides in simulating the early universe in lab experiments. By creating a quantum field simulator using ultra-cold atoms, they're exploring dynamics similar to the early universe and probing mechanisms that govern space-time and particle production after the Big Bang. These discoveries and experiments are leading to new insights and possibly new theories about the universe's birth. In our quest to understand the universe's birth, we've explored various theories and recent scientific developments. We've delved into the Big Bang theory, the widely accepted explanation for the universe's inception, which posits a singular explosive event that set the cosmos into motion. We've also considered alternative theories, such as the multiverse concept, suggesting our universe is but one of countless others, each with its own set of physical laws. Recent discoveries and developments have added more layers to our understanding. From the rapidly growing black hole GNZ 7Q, believed to be a link to the universe's origins, to the massive exoplanet AB Aurigae b, challenging our understanding of planetary formation, and the innovative quantum field simulator that allows us to explore dynamics similar to the early universe. Each discovery and idea propels us forward in our quest to comprehend the universe's birth. Yet, the vastness of the cosmos ensures that mysteries remain, ever enticing us to keep exploring. While we may not yet have all the answers, the journey to understanding the universe's birth is a fascinating one. As we conclude our exploration of the universe's birth, it's worth remembering that each theory, idea, and discovery brings us a step closer to grasping the grand narrative of existence. The birth of the universe isn't just a story of distant galaxies and supermassive black holes, it's also our story. It tells us where we come from and gives context to our place in the cosmos. There's an incredible sense of wonder that comes with understanding the origins of our universe. It's like piecing together the most complex and fascinating puzzle ever conceived. But remember, this puzzle isn't complete. We're still making discoveries, still formulating and testing theories. And that's where the real excitement lies, in the journey, the quest for knowledge. So don't stop here. Keep learning, keep questioning, keep exploring. The universe is a vast and intricate tapestry, and we're just beginning to trace its threads. Thank you for joining us on this journey. We invite you to like, comment, and share this video to help us spread this knowledge to others. Until next time, keep exploring the mysteries of the universe.